Hello everyone, my name's Damon Barnes. I run the technical marketing team within the Bluetooth SIG in the marketing organization. Today I'm going to give a short introduction to the Bluetooth channel sounding feature. My presentation is kind of set up in a specific way to introduce the topic, and then Charlie Ice and Arn Bestman will go into more detail about areas of interest and expertise for their company. In addition, today I'm going to share some early implementation testing results from a couple of our member companies, and then my talk will close out with giving you a little bit of an update on where we stand as far as industry support and the rollout of the Bluetooth channel sounding feature goes. So with that, let's get started. Okay, to start off with, in case you're not aware, a quick intro, like what is the Bluetooth channel sounding feature, or how do we communicate that from the SIG side? Bluetooth channel sounding is a secure, fine-ranging solution that brings true distance awareness to Bluetooth technology. True distance awareness can enhance the performance of any Bluetooth connected device. We're talking enhancements to convenience, safety, and security for end-user solutions. When it comes to the use cases, initially we know channel sounding is going to have an immediate impact on digital key, access control type solutions, as well as find my devices and networks. Here's an interesting scenario to consider though. What happens when you make all Bluetooth connected devices distance aware? You suddenly have this transformative possibility for all Bluetooth connected devices. Here's a few examples to consider. So the first one, Bluetooth human interface devices, or HIDs. Think of these as mice, keyboards, game controllers. If these devices support channel sounding, they could automatically switch between active, inactive states to enhance performance based on their distance from, say, a smartphone, tablet, laptop, or even PC. Another one is Bluetooth human-machine interface solutions. These are, if you're not aware, solutions where a device with the interface is used to command and control devices without an interface. This is primarily in industrial manufacturing type settings where in these scenarios, if channel sounding is supported, you could enhance personnel safety by only allowing the operation of this heavy equipment or even robotics when the user or operator is at a safe distance. And then a third scenario is Bluetooth device networks. A good example of those might be something like wireless lighting control. With Bluetooth channel sounding, these systems could better self-optimize their configuration to enhance the overall performance of the solution or system as a whole. Those are just a few examples. We think Bluetooth channel sounding is going to have a major impact in a number of different areas. Okay, so now before we go into a little bit more detail of Bluetooth channel sounding, from the Bluetooth SIG side, we do like to say that there's this portfolio of Bluetooth device positioning features. Bluetooth channel sounding, of course, is the most recent addition, but these features, they enable one Bluetooth device to determine the presence, distance, and direction of other devices. So these are like the capability areas, right? And for each of the capability areas, there's at least one enabling feature. So for presence, the enabling feature is, of course, Bluetooth advertising, where a transmitting device broadcasts its presence to scanning devices when in a general area. So we know that a Bluetooth device is present, like on premises at the convention center, right? And then so for distance, we now have two features. Historically, that enabling feature for distance measurements being received signal strength indicator, which we refer to as just Bluetooth RSSI. RSSI, of course, enables the receiving device to estimate the distance to a transmitting device by measuring the power level of the received radio signal. So RSSI gives us these approximate distance estimations, which we now refer to as coarse ranging. And then, of course, channel sounding is what's going to give us these precise distance measurements. So we primarily refer to channel sounding as a fine-ranging feature. So more on that later. And then lastly, here when it comes to portfolio of positioning features, we have direction. That's, of course, where Bluetooth direction finding comes into play. You may also know of direction finding as angle of arrival or the angle of departure methods. This is where a receiving device is at a high level determines the direction of a signal from a transmitting device. So direction finding tells us that the device is over there, right? A couple more points on the positioning features. So channel sounding, RSI, direction finding, and advertising. we like to, clarify that there's a feature purpose, key performance metric, and denote whether Bluetooth connectivity is required or not. So for channel sounding and RSSI, obviously distance features. For channel sounding, we like to say plus minus 20 centimeters accuracy, so we say centimeter level accuracy, fine ranging as I mentioned. For RSSI, because it's based on received signal strength, there can be a lot of variability with distance estimations when you're using RSSI as the distance increases between the devices. If there's obstructions, interference, things like that, the accuracy is going to degrade, right? So here we say plus minus 20% of the actual distance and coarse ranging. And then connectivity, this is a key thing to keep in mind. So channel sounding is connection oriented. That means the devices need to be paired bonded, have a paired bonded relationship. RSSI can be connection oriented or function in connectionless scenarios. And direction finding, so obviously with direction, we're measuring that in degrees. So we say plus minus 5 degrees accuracy is what you can typically expect. Direction finding can be used in connection-oriented or connectionless scenarios. And then lastly, but certainly not least, is advertising. Obviously, I mentioned presence for advertising. As long as you can, hear the signal, you can determine if a device is present. So 100 meters accuracy and, kind of typical environments, unless there's like major obstructions or interference with no problems. And of course, advertising is connectionless. Now let's turn to getting into just a little bit of the detail of what is Bluetooth channel sounding. So I mentioned it previously, but Bluetooth channel sounding brings secure fine ranging to Bluetooth technology. It's a complete solution for secure fine ranging, by the way. Regarding the fine ranging aspect of Bluetooth channel sounding, this is based on phase-based ranging, this well-proven method in RF engineering for measuring distance between wireless devices. And then on the security side, there's multiple security features to mitigate the risk of wireless ranging attacks, such as device spoofing, man-in-the-middle relay type attacks. And there's multiple levels and multiple features where you can basically toggle your security based on your application needs. And then third here is, I mentioned it already once, but true distance awareness. Channel sounding brings true distance awareness to Bluetooth connected devices. And here, let me take you through an example. So what this kind of means is that a Bluetooth device can now better understand its position or location with respect to other devices it's connected to. So the smartphone, take for example, will have a better understanding of its position in relation to the door lock that you see pictured. And that means the door lock will better understand when the smartphone is close enough to automatically unlock or automatically lock as the smartphone moves away from the lock. When it comes to performance, again, we say Bluetooth channel sounding enables centimeter level accuracy devices. And we do have some early implementations that have achieved plus minus 20 centimeter accuracy up to 100 meters. So that's a really strong result, especially considering that this testing was done early on. It was right around when the standard was adopted. And so from the SIG side, we're super excited about this result at this stage. And we believe that over time, the performance is only going to improve as the implementations mature over time. All right, so now taking a quick look at the impacts to the Bluetooth LE stack that channel sounding brought. Bluetooth channel sounding introduces, for all intents and purposes, a new physical layer to Bluetooth LE. There are new physical links for Bluetooth channel sounding. These links are what's used for the exchange of data that's to be used for distance calculations. Channel sounding also adds a new channel map. There are 72 channels, 1 megahertz wide spacing. So that's at the physical layer. If we move up a layer to the link layer, you have a number of new procedures for Bluetooth channel sounding, as well as clock updates. Then if we move up to the next layer, maybe not the next layer, but if we move up to the host controller interface, you've got new channel sounding specific commands and events, which I'll touch on in just a moment. And then at the gap layer generic access profile, this is where new device roles are defined, the initiator and reflector, and there's also 4 new security levels that are defined as well. So that's a quick whirlwind tour of some of the stack updates that Bluetooth channel sounding's brought to the Bluetooth LE architecture. Okay, so now getting into channel sounding operation, how does it work, at a high level? The guys will go into a little bit more detail on this, of course. So channel sounding takes place in a one-to-one topology. I mentioned the devices have to be paired bonded. And then there's the two new roles that I mentioned. There's the initiator role and the reflector role. The initiator, this is the device wishing to calculate the distance to another device, and then so the reflector, as the name alludes to, is the device responding to the initiator. If we start at the top, the application layer, this is what provides configuration choices and preferences that are suitable for the two device, and that's using HCI commands. Then a channel sounding procedure, if you look down at the controller portion of the visual. This is where the RF signal exchanges or tone exchanges, if for phase-based ranging, that produce phase and time delay data, for instance. Distance is then calculated by a ranging algorithm that resides at the application layer, using data that's passed from the LE controller to the application layer in HCI events. So that's how Bluetooth channel sounding works at a high level. So now let's transition to the two ranging methods that are available and talk about just a little bit about those. Okay, so first is phase-based ranging. I've touched on this previously. The purpose of phase-based ranging in the channel sounding solution is to get high accuracy distance measurements. If you take, for instance, this image, the initiator device, the smartphone, the way it works, it'll choose a frequency 1, and then send a signal or tone rather to the reflector device, which then returns the tone on the same frequency. This process is repeated across multiple frequencies. Distance between the devices is calculated based on the phase differences between the transmitted and received signals over those frequencies. So that's how phase-based ranging works at a high level. Now let's turn to the other ranging method, round-trip time. Okay, so round-trip time is pretty interesting. Primarily, the main purpose for round-trip time, or RTT, is to enhance the security of a Bluetooth channel sounding solution. Additionally, Arn's going to touch on some other benefits of the RTT feature, and so I'll leave that to him to go into later on in the session. The main purpose, though, for RTT out of the gate, though, that we like to talk about is enhancing security of Bluetooth channel sounding. So unlike phase-based ranging, where phase can potentially be changed, like in a really complex attack, RTT is based on time of flight, and time can't be reversed. So what we're looking at here is RTT can be used as a countermeasure against sophisticated man-in-the-middle relay attacks. In RTT, the way it works at a high level, the initiator, it's going to send, or it has the option to send a cryptographically scrambled packet to the reflector device, which then returns the packet time of flight, right? And then distance is calculated based on the round-trip time. These calculations can be used to validate phase-based ranging measurements and then help identify wireless ranging attacks such as man-in-the-middle relay attacks. And so what RTT is doing here in this type of scenario is acting as a secure distance bounding technique, providing independent distance measurements to cross-check the phase-based ranging measurements. So, and this can be used to significantly reduce the risk of man-in-the-middle relay attacks. And that's why we like to say by combining phase-based ranging and round-trip time, channel sounding enables secure and accurate distance measurements between Bluetooth-connected devices. Okay, so now let's pivot to an alternative or an additional topic, is support for antennas. Bluetooth channel sounding is really flexible in that you can support different antenna setups. And I should point out that you can get really accurate results when the devices just have one antenna each or one antenna path. However, there's also support for 2-pass, 3-pass, and of course 4-pass. And the diagrams here kind of outline the different support scenarios that are available. This figure, I should note, and much more detail can be found in the Bluetooth channel sounding technical overview paper, and I provide a link to that later on in the presentation as a resource for additional reading. A couple more points on support for additional antennas, though. There are certainly, benefits, as many of you probably already know. Of course, you can improve the accuracy of a channel sounding operation. Additionally, support for multiple antennas provides alternate path options, which can help with interference mitigation, and likewise help with better distinguishing the shortest path when reflections are present, which is often the case. In the testing data I'll share shortly, you'll see some of the impacts potentially of where multiple antennas can play an interesting role. Okay, now a topic on standardization of ranging data, which is where the ranging profile and service come in. These are two higher layer GATT specifications for Bluetooth channel sounding. The ranging profile and service, they define the interoperable exchange of channel sounding ranging data for distance calculation. And just as a refresher, profiles, these set the rules or configurations, for instance, for channel sounding for ranging data exchange. The service, it's what contains state data and supports specified operations for that specific data. Together, these specifications, they standardize how a distance measurement application can read these ranging results from a remote device, as well as configure desired content, the delivery method, and arranging parameters. And so here's like a high-level example of how it kind of works. So the smartphone, functioning as the GATT clients, is going to request ranging data from a door lock, which is operating as the GATT server. This door lock's then going to forward ranging data to the smartphone through the ranging service, The application running on the smartphone is going to process this ranging data to produce these distance calculations. And so one more note here. So the ranging profile and service targets a broad set of use cases. Sometimes these profile specifications are use case specific. That's not the case for the ranging profile and service. They can support digital key, locks, Find My, control solutions, and other use cases as well. So not use case specific. All right, now distance measurement algorithms. At the application layer, as I've kind of alluded to and mentioned at least once, I think, that's where the distance measurement algorithm resides. Channel sounding, the feature, provides standardized techniques to determine signal phase and time delay information, for instance, which can be used by the distance measurement algorithm to actually calculate the distance. Bluetooth channel sounding doesn't define a specific distance measurement algorithm, and here's one of the key reasons. The appropriate distance measurement algorithm or configuration setup may vary depending on the application. Thus, the inventors of the Bluetooth channel sounding feature felt it would be best to exclude the algorithm from the channel sounding specification. That means the distance measurement algorithm can be sourced or developed independently, depending on company preference. One last point, algorithm selection does not impact interoperability at all. Okay, so now my favorite part, sharing some information on the early implementation performance testing results that we have. So Samsung and Lambda 4, thank you very much, Arn, partnered up to perform some early implementation testing for us. For the testing, they used these prototype smartphone boards that Samsung provided, of course. The testing was done outdoors, clear line of sight. The devices were stationary, mounted at about 1 meter high, and they ran tests with 1, 2, and then 4 antenna paths, thus the talk about antenna paths previously. And then transmit power settings for 2 of the test scenarios were set at +0 dBm, typical transmit power for Bluetooth LE devices, and they did toggle it once at the power setting up to +10 dBm for one scenario of test, for the last test scenario, All right, so I need to caveat again, these were early implementation test results. The results may vary. We at the SIG would hope that over time some of these outliers that I'm going to show you will smooth out over time. But overall, the results were quite nice, which is why we are sharing the data today. Okay, so the first test scenario, the devices each had 1 antenna, so 1 antenna path. The transmit power was +0 dBm. If you focus in on the line of sight row here, you'll see that we we had really consistent results across the board. At 1 meter, or about 3 feet, we were spot on with the distance measurement. 50 meters, we were plus minus 20 centimeters, so a really good result. Our outlier, in this row, if you will, was maybe at the 10-meter mark, because you see at 20 meters the performance or the result actually improved. And then the second row is a back pocket testing scenario. Let me take just a sec to explain a little bit what that is. So in a back pocket test scenario, you still have one device, call it the remote device, that's mounted as mentioned previously. But in this scenario, a person takes a smartphone and puts it in their back pocket and stands in between the two devices when the signal exchange is run. So you have interference, you have this big bag of water that's basically blocking the signal exchange. So it can be one of the more challenging test scenarios for locationing and distance measurement, especially like in automotive type use cases. So for this scenario, you're going to see some degradation in performance, right? But the metric that we're looking for here is to be plus minus half meter or 50 centimeter accuracy or better. And as you can see now on this row, we did meet that mark for all test scenarios except for 5 meters. I'm not going to, mix things up or anything on 5 meters. We didn't have a real good result there, but so the team was looking at that, and that was one spot where early implementation testing we attribute that to, or an early implementation solution. Excuse me. Okay, so the second test scenario, the devices. One device had 2 antennas, and the other device had 1. So 2 antenna pass. Again, the transmit power was plus 0 dBm. Here, you take a look at the line of sight row. We had excellent performance across the board, very consistent, spot on at 1 meter, plus minus 10 centimeters at 50 meters, which is excellent. And the thing about the Bluetooth channel sounding feature from the SIG side that made us really excited is just the consistent performance that you see over increased distance is quite amazing. Especially at this stage of where we are. And then in the back pocket testing here, you see that we met the mark for all of the tests, fairly consistent performance all the way up to 50 meters. The last round of testing here, the smartphone boards each had two antennas each, so we had 4 paths here in this test setup. Here they also cranked the transmit power up to plus 10 dBm. Then on the results, the line of sight row, focusing in on that one, we had pretty nice results overall. You see, interestingly, we weren't quite as accurate at 1 meter, but it's still a really good result. Exact same performance at 50 meters, consistent performance all the way up to that distance where they concluded testing. Then on the back pocket row, again, we had pretty good results here. We didn't have as good of results, interestingly, at 5 meters or 10 meters, but it's still really close to where we want to be. And so we think over time, with tuning and optimization, that this test setup would be quite good as well. So from the SIG side, just to reiterate one last time, we were super happy to see these results at this stage of the channel sounding feature being still quite new overall. And so we wanted to share this data with the public, and we thank Lambda 4, we thank Samsung for taking the time to do this work for us. All right, so now let's start to kind of wind things down a little bit, at least from my side, and talk for just a minute or two about support for the Bluetooth channel sounding feature. I can say that there's really solid support from what we call the enabling technology side already for the Bluetooth channel sounding feature. Chipsets, modules, stacks. There's a number of qualified products out there today. If you were to go down to the show floor, you see, semiconductor companies, many of them, I should say, have a channel sounding demo, which is nice to see. Some of them are really cool, and they're getting pretty good results as well. On the in-use product side, we're still expecting products to support the feature in 2025, smartphones, tags, and fobs. I wouldn't be surprised to see a smartphone or two supporting the channel sounding feature, before mid-year this year. And the reason I say that is because we see and know that there's going to be support for Android, for Bluetooth channel sounding, Android 15, QPR 3, which includes APIs. And then the link that I provided for you here to the code search portion of the Android website, if you were to search channel sounding, you will see that at a minimum there's support for the ranging service client and server framework. There's also a channel sounding test app. And so that tells us that support for Android is going to be there. So we're super excited about that. And so a few takeaways. If I were to leave you maybe with 3 key things, I would point out the following. So the Bluetooth channel sounding is available in Bluetooth Core 6.0. That's the core specification where channel sounding surfaces. As mentioned, Bluetooth channel sounding enables secure fine ranging between Bluetooth connected devices. We're talking centimeter level accuracy. The test results I just showed you display that. And then, we know there's going to be support in Android, and so that means that the adoption of the channel sounding feature is likely going to be there for both the platform side and on the enabling technology or peripheral side, And here are the resources that I mentioned. One resource that I haven't mentioned so far in this talk, we partnered with ABI Research, and they produced this Bluetooth channel sounding market research notes, which gets into the industry impacts, what's needed to see broad, ubiquitous adoption of the Bluetooth channel sounding feature. So that's a really good resource. It's not too long, worth your time to check it out. I mentioned the technical overview paper. That's a paper written primarily for developers that goes into all the detail of the Bluetooth channel sounding feature. My team authored that. We're super proud of that, and that's there for your continued learning. And then I mentioned the core specification. I've also provided links to the ranging profile and service specifications. So that's the material that I had to introduce the channel sounding feature, talk to you a little bit about the test results and industry adoption, and thank you very much.